6.8, graphing radical functions. We're going to be doing more transformations, so this should be very simple for you guys because we've done several sections of transformations. So this is just review, really, except for now we're just doing it with a radical graph. All right, so radical functions can be written in the form of f of x is equal to a and times the nth root of x minus h plus k. And recall that the a part is your stretch or compression. The stretch would mean it's a whole number. Compression would be a fraction. Okay. H is the horizontal translation, which always moves in the opposite direction that it is. K is the vertical translation, moving up or down. And if A is a negative, then it is a reflection. All right, so if we have parent functions of a square root is the simplest form, which would be as y equals to the square root of x. The parent function of any other radical would be y is equal to the nth root of x. So you could have the cube root of x, fourth root of x, whatever. A reflection would be if it was negative. A stretch would mean that it would be not a fraction. So if this a was a 2, that would be a stretch, but if the a was a 1/2, that would be a compression. And translation, that means anything opposite of what's inside. So if it was an x plus 3, then it would be shifted to the left 3. If it was an x minus 2, then it would be shifted to the right 2. Okay, so we've worked with these several different times. This should be very simple for you guys. All right, so let's graph a parent function. Square roots, if you want to pull up your calculator, and I'm going to show you what you can do. We'll go back to this. Clear this out. Clear all this out from the last video. All right, so if I wanted to look at the square root of x, which is the parent function of the square root, and I graph it, well, we're going to definitely need to put it back on the right window. Zoom 6. All right, it's always going to start at the origin, okay? It will never be, unless it's been shifted, it won't be down here, okay, below. But it's always starts at the origin for the parent graph. And as you can see, it goes up. And if you needed to look at the table, you can see it goes up, you know, very gradually, but it continues to keep on going up. Okay, so if we were looking back at, and we needed to get some specific points, you could have a point at 1, 1, and then another point at 4, 2. Pick out the ones that are whole numbers. So 1, 1, and 4, 2. All right, so I'm going to put a dot at 1, 1, which is right there, and 4, 2, which is right there. And again, this is going up from the origin, and like that, okay? And it's very simple. You can always double check with your graphing calculator the way that your graph should be looking. Anytime you translate it, you know, you can graph it by hand, and then if you want to check it by your calculator to see if you graphed it correctly, that would be my advice to you, to make sure that you get the points on there correctly. What this is saying is the domain for this one is going to be anything from 0 on your axis greater than. So any number, so we're going to have x greater than or equal to 0. Any number that's bigger than 0 would be my domain, because your domain is your x values. My range is any number y greater than 0 on the parent graph. Okay? All right, so let's do the next one. This one says that square root of x minus 2. Now, one of the things that you might want to make a note, let me write it up here somewhere, that the domain, whoops, why is it not writing? The domain if index is an even number, then greater than or equal to opposite of h, okay? Because remember, the opposite, if it's underneath the parentheses, is the way it's going to shift, okay? So we'll see that right in this one right here. This one not so much because this is not all under the radical. This is a vertical shift, but because the -2 is not under the radical, it does not have a horizontal shift, okay? So remember this for the domain. If it's an even index and it's all underneath the radical, we'll deal with that with this one right here. And I'll show you what I'm talking about then. All right, let me get a color. All right, so normally it starts at the origin, but this one is going to be shifted down too. So that means I go down 2, okay, and if I used to be at 1, 1, then I'm going to be at -1, -1. And if I was at 4, 2, then I'm going to be shifted 4 right here. Yeah. I'll double check that with my calculator. Okay, it's just shifted down 2. So let's look at it with the calculator. Let's go back. So that's going to be -2. And then I'm going to graph it just so you can see what it looks like. Starting down there, and mine is a little bit off because I can see that it doesn't go up that fast. Then I'm going to go to my table, make sure I get my points right. So it should be at 0, -2, and then it should be at 1, -1, and then it should be at 4, 0. So I went too far up. So definitely want to go back and fix that. Too far up right here. All right, so 1, 1, and 4, 0. So it should go like that. And it's still a little off because I'm writing with this pen, which is a little funky. All right, so now our domain is going to be x is greater than or equal to. We did not shift, any further left, so it's still going to be greater than or equal to 0. And our range, though, will change. Our range is going to be greater than or equal to. It's shifted down, so now anything above -2. So greater than or equal to -2. All right, now this one. This one says x plus 4 under the radical. So that means it's going to be shifted to the left 4. So we're going to start right here. Okay? And remember it was up 1. And then it went, let's see, this was 2, 4, should be right there. And going like this. We'll check it. So let's look at the graph. All right, so now I'm going to go back and change this. Go back, oops, move this over. Oh, maybe not. Go back, delete, go back, delete, go back, and delete that parenthesis because I've got to put all of it underneath there, and that's going to be a +4. +4. Now for the parenthesis back. Now graph it. Let's move this over. Alright, as you can see, it's shifted over 4. And let's look at the table to make sure I have my points in the right place. So at 0, 2, yep, and -3, 1. Good job. Okay, got that one right. Yay! All right, so let's look at the domain. Now remember, domain is x, and it is greater than or equal to. Now what is the smallest x? The smallest x is at -4, so it's going to be greater than or equal to -4. Remember, if it's an even index, which this one was, it is greater than or equal to the opposite of the h. Well, the opposite of +4 is -4, so therefore that's my domain. My range did not change from the parent graph, so that's greater than or equal to 0. Okay? And let's see, did I have any more on there? No. All right, so we're going to practice these. These are very, very simple. The main thing that you need to do is practice graphing them. You can use your calculator to check your work, get some points, and also you need to go back through your domain and range, and there's never enough practice understanding that. If you have any questions, come see me. Thank you.